This is going to be a very non-greenwashing, green-wishing discussion. And it's also very difficult, right? Because we're talking about scope 3, which is the Wild West. How do you measure it? How do you track it? How do you manage it? But at the same time, we still need to do our best given what we have. So I'm going to let the panelist, Ian, if you'll start, and then introduce yourself and your company, and we'll get going.
Yeah, hi everyone. Ian Whitfield, Pure DC, data center operator, footprint in UK, Ireland, Middle East, Asia. Heavily involved in engineering sustainability. So looking forward to the conversation.
Hi, I'm Sophia Flucker. I'm at Operational Intelligence and MySim. So we provide services throughout the data center lifecycle. At OI, probably 80% of that is commissioning. At MySim, it's very much on the construction side. But we've always had a keen interest in sustainability and doing some research into how we can improve what we're doing.
Ed, Ansett, i3 Solutions Group, data center consulting engineers. How about that?
Alex Brew, Regional Director for Northern Europe at Vertiv. Most of you will probably be aware of us. We're a reasonable size player in terms of manufacturing and servicing of critical infrastructure solutions within the market globally.
Hi everyone. Hi Loren.
Hello.
I'm Eva Gkenakou from Prosperia Consulting. We help businesses develop and implement ESG sustainability strategies, come up with sustainable supply chain strategies, and supporting ESG reporting.
Okay, so the first question, let's talk about the new requirements that are coming in. And there were panels this morning, so we don't necessarily talk about them, but what do those mean? And I guess I'm gonna hit at first the consultants. What does that mean for data center design going forward? What is gonna change from what was to what will be?
Which specific requirements are you talking about?
You take your pick, because there's a whole lot to choose from.
Yeah, okay, so principally, I think the central characteristic of the various regulations and in some instances guidelines is to try to coerce our industry into doing something proactive in terms of its carbon abatement. So what does that mean? So the way many organizations have tackled this is through their energy sourcing. Okay, I mean, people have done the obvious things like trying to improve their operational efficiency in terms of cooling overhead and one thing or another. The main way that people have addressed this, in my opinion, is through sourcing renewable energy, through PPAs and so on. I personally think, we had big talk about liquid cooling and so on, the impact of that, so we'll put that one aside for now. I personally think the most significant thing the industry can do is to participate in grid support. And because that's, see, when you look at things like the purchase of renewable energy sources, that's fine, that's doing something financially. And a lot of companies claim to have been carbon neutral since X years because of the approach that they've taken. But there are things that you can do that can actively move the needle. And the main thing that we can do in terms of supporting the grid, which by the way is absolutely essential now because the grid requires support. I think governments will mandate organizations to participate in grid support to obviate the grid emission factors. In other words, to make the grid emission factors less carbon intensive.
Okay, Sophia, talk to me more about design and construction. So really more scope 3, where do you see that, the regulations having an effect there?
Sure, so I mean, I think the business case for improving operational energy use has been there for a long time, and people have been making improvements in that area. It's very transparent, you can measure it. Energy prices are increasing, so you save money if you save energy. Everyone's doing that. They can still do better, but you know that's quite well established as an area. I think what's not well understood or reported or transparent is people's Scope 3 impact. And we know that for the most part, Scope 3 is really the biggest part of everyone's impact. So I think if the regulation is going to make people be forced to be more transparent in their reporting and actually change behaviours and trying to make it joined up so that we're not reducing our energy and use, but then having a negative impact, just causing a burden shift towards that embodied impact. I think it came up in the last session around what happens to your servers at the end of their life. We know that that's massively impactful, but how many people are actually doing something about that? How many people are reporting on it transparently, or do they even know themselves internally what kind of impact do they have there? So we can't just kind of stay where we are and keep doing what we're doing. There's a whole load of things which I think people are not even touching on as yet.
Eva, do you have anything?
Yes, well, if you allow me to take a step back, so looking at the bigger picture and going back to your previous question about how the new regulations will be affecting the way data centers are designed and built going forward, if we look at the bigger picture, we are admittedly currently facing the largest threat to humanity that has ever existed. And we are finally, if I may say so, seeing the regulations coming in that are aiming to unlock capital flowing towards greening the economy and the way we do business rather than continue with business as usual. And then as part of that, if we look at buildings, construction of buildings, building materials, these, according to studies, account for roughly 40% of global emissions, and those buildings include data centers. So there's currently an avalanche of regulations, like you implied, both local ones and globally, but they finally seem to be converging as well in their content and requirements. So these regulations have traditionally looking at energy efficiency, but they are now becoming much more holistic, looking at embodied carbon, which is part of Scope 3 that you mentioned. And there are now various standards where we can see what is considered to be part of that Scope 3, like the UK Net Zero Carbon Building Standard, other local regulations for buildings. And if we try to see some patterns across that, I would say there are three things that the data centers need to have. One is to be low carbon in design, green power, and the materials and products used. The second one would be to be able to provide granular detail, both in terms of energy efficiency and data being used. And the third is to be resilient in a changing world. And we are talking about a changing world in terms of both climate, so the data centers need to be resilient in terms of temperatures, extreme temperatures, water scarcity, weather disrupting manufacturing and transportation, if we're talking about developments, redevelopments, but also changing economy. So like you mentioned, and Sophia mentioned, customers and governments are encouraging where products are made. For example, we see in the US, the Inflation Reduction Act, the cost of energy is changing, and we have scarcity of minerals that are critical to the green transition. So all of that needs to be taken into account.
Yeah, and that's a great point, and I actually want to hand it over to Ian. The question that I've got for you, and then I'm going to turn it to Vertiv. We all talk about wanting to make things better, more sustainable, greener. Are you seeing customers willing to pay more for that?
Give me the tough one. So, in practice, no, not yet. I think think there's a desire, it's a problem coming, right? It's a cost that we're all having to carry to some degree, because we were chatting earlier, weren't we, about the fact that we can't move to where we need to get to without more data and without innovation and all these, and without seismic shift in renewable energy availability and all those things. And we've just done, where all of this has hit us literally just off the back of 2 years of massive supply chain restrictions and all of those things. So we're kind of solving multiple problems at once. We've had 2 years of huge inflation, certainly in the UK. I'm guessing it's much the same in well, we're seeing it in Europe and Middle East and Asia, frankly, where we're operating. And therefore, we're all kind of tackling multiple problems at once. So at the moment, our customers are hyperscale customers, as many of yours are in the room, and they're telling us they need that cost per megawatt is driving their primary business decision. Of course, they appreciate that sustainability is a thing and that it needs to be sustainable, but the key driver is cost per megawatt and cost of energy. And we've seen a massive spike in energy costs, obviously, in the advent of the Ukraine issue and so on and so forth. So that said, I think some of the pathway to decarbonising our facilities, coming back to design and construction and scope 3, for example, is doing the same with less. We're seeing an opportunity to deliver the same IT megawatts with less redundant, wrong words there, with fewer components, if you like. So so trying to be smart, less concrete, less steel, hitting the same things, so that actually we can kind of solve our problems at the same time as delivering on others. So.
Okay, so while Pure is getting beaten up by the hypers to do more with less, and by less they mean less money, what have you seen?
By less I meant less resources.
Oh, I know what you meant.
Yeah.
I'm saying what you really meant.
Yeah.
That's okay. I'll speak for you.
I think actually, sorry,
just
I think we're moving to a place where actually we have got an opportunity down the line, perhaps, to package data center services with an appropriate carbon story, and therefore the opportunity to increase our customer stickiness, the value of the deals we do with them is there as well. So
yeah, well, no, I'm
not
going to
It's
come
not
back
there
to you
yet,
in a
though.
second. Go ahead.
No, you're definitely right in the sense that there is a somewhat of a disconnect between, like you say, a lot of the willingness to do better and how we see that materialise in the market in terms of the designs, the challenges we have around cost, and those ultimately all flow down from the clients of our clients, in the case of Ian and so on and so forth, where yes, there is a willingness to do more, but fundamentally, we have to engineer and deliver these solutions in what is a very competitive landscape for, the data center operators, for us as manufacturers, and to really innovate and deliver the types of technology that we need to push more towards scope 3, which we are doing. That does come at a premium, because naturally we have to invest, we have to employ considerable amounts of R&D efforts to bring the technologies to market that are going to facilitate this next sort of paradigm shift, as it's been said, in terms of how data centers are operating, be it interfacing with the grid, be it heat recovery, all the themes that we've discussed in detail today. But there's a premium associated with that at this point in time. Things will, as we see wider levels of adoption, as we can scale our manufacturing efforts with a kind of a broader uptake from the market of these types of systems, naturally things will become more competitive. But certainly clients have to recognise that we will have to do a little bit more, and that means we'll have to part with a little bit more in terms of cash to make it happen.
Yeah. All right, so we're gonna go in inverse order now. So now I want to talk about, and I'm going to pick on another group, and I'm not really picking on them, but uptime and their tiering standards, right? The data center, and they're my punching bag for what we experience as an industry, that our customers have an expectation of how many 9s and this and this and this, and how many F5 tornadoes actually go through the area where we build an F5 tornado-proof data center. What do you think that we need to be looking at from an industry as, maybe we don't need to be that resilient, because the additional cost, both in money and in embedded carbon, isn't worth the incremental resilience that it adds. And will customers agree with that or not? And I'll start with Vertiv, and we'll just go backwards.
I think, yeah, and I've had this discussion with a couple of people today around that legacy behavioural trait of being so risk averse. It has been drilled in. You know, we know that data centres are, you know, the beating heart now of society in terms of what keeps everything live and operational. But there is a tremendous amount of resilience that's been built into the broader networks over that time, which does perhaps mean that we can start to challenge the norm in terms of, you know, the risk levels associated with the individual sites that we're looking at. And, you know, that's I think is probably one of the biggest blockers of the adoption of things like liquid cooling, is the fact that it's just this unknown entity somewhat, and the traditional people that we're dealing with on sites that have become very accustomed to a very particular way of doing things and a very recognised way of doing things for quite some time, find it very, very hard to identify with these new technologies and how that will change and what the risk profile will do by stepping away to doing that. How we combat that is difficult. You know, we as a manufacturer, you know, we're in a privileged position as a very large manufacturer because we have a huge service workforce, and you know, so we are making investments into a liquid cooling portfolio, and we know that we can deliver that with a service offering that will give the same level of comfort to our customers that they have had with those traditional types of technologies that they've been utilising. And that's going to be a key enabler for us, we think, in that sort of space. And the same goes for grid interfacing type technologies and how we start to work with aggregators to provide those levels of comfort. But we have to mitigate that kind of the risk of compromising on, you know, people's resilience.
All right, let me ask the guy signing the SLA.
So I guess there's a couple of points here, isn't there? I mean, just as a side note, we talked about uptime and tier 4 earlier. You can actually achieve tier 4 with an N+1 system, so you don't need 2N. You just got to be smart and think about how you do things. So there are perceptions, and yeah, I guess we're all facing the court of public opinion with sustainability anyway, so nothing unusual there. I think where your question was coming from is what can we, where can we work with maybe the Ashrays of this world and so forth and our customers to kind of drive SLAs, the environmental operating envelopes that we operate their kit in our facilities to do more. And absolutely, we've been pushing our own facilities up in temperature terms over the last 12 months actually, and we really should be pushing them further. We are just starting to have those SLA conversations and just say, look, these are all the commitments that you're making as an organisation publicly. This is what your buying team are giving us in a contract. The two don't meet in the middle. So what do we need to do to have that conversation? Meet the themes of what you're trying to achieve, but do it in a sustainable way. So let's operate at somebody mentioned 24 degrees, and let's operate at 28 degrees or 30 degrees, frankly. And yes, those conversations need to be had. And I think the industry is only going to get anywhere close to achieving good things by collaboration, competitors, peers, the whole kind of value chain by having those conversations together and pushing on some of those issues.
I'll toss in, I think regulators are going to have to step into, because all the hopium in the world isn't going to.
I will add actually that we are finding our customers are willing to listen to sensible ideas if they come from a logical perspective of we're prepared to stand by it, but and you've asked for this, we can sensibly meet that, whether it's hours of fuel storage or minutes of UPS autonomy or whatever it might be, or we want column-free data halls. Well, do you realise the impact of that? How much embodied carbon goes into the concrete and steel in our data centres? We can achieve 20% savings in the superstructure of our building, carbon savings, I mean, by not doing that. Therefore, that has an impact on our accounting, which has a kind of a secondary impact on yours. So definitely those conversations are easy to have now, because we can provide science, engineering data to back up why, and morally, it's very hard to push back on some of this stuff. So.
All right, so so Sophia, the next one's for you, and actually Ed and Eva as well, but so often in our industry, you know, and I see this especially in emerging markets, where, you know, this is how it was done in Northern Virginia, therefore, you know, this is how it was done in Paris or Frankfurt, and therefore this is how it must be done in pick your next city, and that is absolutely not okay. So, you know, not sure the geographical breadth of the audience, but what are the different design and construction considerations depending on where it's at?
Yeah, I mean, I think it kind of continues on from the previous conversation. It's all about managing risk, and I suppose perceived risk is not the same as real risk in a lot of ways. You know, you can make it very simplified and say, well, any change is a risk, but the reality is you can't do everything as you used to do it. We have to be in a changing world and to adapt what our solutions are for the given clients, the location, the restrictions that you have there. There's a lot of talk about water, and people are kind of worried about the increasingly visible impact of water use. I think a lot of that has come as a reaction to trying to reduce electricity use. And this is where things are not very joined up, because yes, you might be using a lot more water on site, and that has a local impact, which you're in a drought impacted area, that's not good optics at all for your local community. But actually, what about your indirect water use? The fact that you're probably using a lot more water on site, but actually overall you're using less water, your net water usage is less because you're using less on the electricity generation side of things. So yeah, I guess you do definitely have to look at what are the local conditions. I think part of that, something that we haven't really touched on so far, but a lot of this is around the people side of things as well. So you can build in lots of resilience. You can have your tier 4 data centers. It can be certified, all of those things. But who are running these facilities? You know, a lot of the issues that we have with reliability are around this human interface. And when things go wrong, do people know how to react? Are they trained? Do we have a skills shortage? All of these things. Do you have the local support for whatever product it is in a given location? I think we really need to kind of pay attention to what your local limitations are.
Yeah, I was going to say, and Ed, I'm going to let you go next, but for example, heat reuse. Great for Northern Europe. Not necessarily so applicable in Morocco. And so, you know, and it's when we come up with policies like the EU's just done, no, you don't necessarily, there's not a one size fits all in this industry. So, Ed, I'm gonna let you, what have you seen from your customer base in terms of specifically some innovative ideas around construction and design based on the geography and the environment?
So, you will know this better than most, but what you do geographically is very, very important. I mean, the number of times I've heard organizations say, this is our reference design, whether you mention Northern Virginia or wherever it came from, let's roll it out across the world. It simply doesn't work. You've got to be geographically sensitive, not just to the issues that we're discussing today, which is predominantly environmental issues, but also performance-related issues as well. There are countries where you deploy data centers, they can't even get diesel to run. They can never mind electricity. They can't even get diesel to run on. Okay, so and the grid is so unreliable, they have 2 strings of diesel. So that's almost the antithesis of what we're looking for and what we're talking about. Whereas in a more developed country where the grid is more stable, hopefully the grid has got lower grid emission factors, and you can draw on renewable energy sources. And also we've got a sensible and intelligent client that understands the sensitivity between making the right decisions from a public standpoint, from a climate standpoint, and performance, and they're able to balance those things. These are very different worlds that we're looking in. So and then you've got the whole problem. I'm sorry if I'm making it complicated, because it is complicated. You've then got the whole issue of the data center ecosystem itself. We keep talking about data centers. What is a data center, for God's sake? Because it means everything different to everything else. Yeah, if you think about it, we're now starting to talk a lot about AI and what that means. Probably tier 0, probably tier 1 for particular types, okay? And then we've got obviously old-fashioned enterprise, we've got hyperscale, we've got edge, we've got colo, we've got end-user owned, on-prem, off. I mean, you cannot sit here and go, this is the solution. You have to say, right, where am I? What's my situation, and what's the best I can do in that situation? One of the dangers with regulations is that they might be well-meaning. They need to be mindful of the particular situation that exists in a particular geography. I think it's very important. Very, very important.
Thank you. Eva, do you have any examples from your customer base or clients that you've worked with of innovative, climate-neutral design construction ideas?
There are coming through as was mentioned this morning, there have been goals set, but not necessarily the transition pathways worked out. So as work is being done now, the clients are really looking into the data that they are starting to get. Exactly like you were saying before, they are trying to now challenge the way things have traditionally been done to try and see through innovation or just purely challenging the traditional way of doing things and say, do we really need all that material? Can we only use that material? What else can we do? Can we think outside the box in a way? I can see customers are really willing to challenge the design, but sometimes on the other side, the flexibility isn't really there at the moment because, you know, as people, we develop a way of working, and once we feel comfortable with it, we keep applying it. So I think this is a challenge for us and education institutions and so on. How do we develop the skills that we need? You can call them the green skills, but it can be skills to be more adaptable, to think differently and adapt the design in specific situations. And there is a skill gap there, I think, in the designers, if you don't mind me challenging. Not all of them, of course. There are some great ones that are really pushing the boundaries and want to be innovative, but others are really struggling with bringing new ideas to the table to the clients, and it's more down to the clients asking again and again, how can we improve this from a green side?
Sorry, I've got a question. So one of the things that when I was writing this, and you're looking at things like EPD certificates, and you're looking at how you calculate the carbon when you're in the construction phase, right? And lots of this data is becoming more widely available. It's becoming required as part of the tendering process. You know, do you feel that we're starting to get to a point where we actually know what our embodied carbon is on a construction project, and then we can refine it, right? So how accurate is our current embodied carbon on, let's say, on a pure data center? How well do you know it at the moment?
Pretty well. We've spent a lot of time. So we're in flight on a couple of schemes, and we've got a couple of schemes that are live, and we've had our life cycle calculations validated and independently verified. We're getting into that realm where public disclosure is staring us down the barrel, and the last thing we need is a really bad PR experience, right? So we've got to a place where we've got some exact figures for each of our facilities, and we've got some good metrics coming out of our facilities. So, you know, so many 100 tons per megawatt, for example, as data. We've then taken that and sort of going back to the question about some of the ideas that are making a difference to Scope 3. So our legacy data center, for us, we're quite lucky. We're a relatively new platform. Is a couple of years old, right? So we don't have any of the legacy stuff that's got some of the things that many of the larger platforms are going to have to solve for. But so we don't have water use in operation, for example. We can play with the temperatures in the data halls and kind of the efficiencies out of the operations, but we're actually, if you look at our scope 3, the big thing is concrete and steel.
Well,
So
but you can
50
make decisions on that now, right?
and
Now you've got the
and
numbers.
we are making decisions on that, and we've got a pathway to knocking about 50% of embodied carbon out of our scope 3 on future facilities if we go all the way to a mixture of biogenic materials like timber structures, for example, concrete, low carbon concrete within biogenic embedded material, recycled steel, and so on and so forth. If I take a current project that we've got, it's a pretty big superstructure, we can procure about 50% of the structure with low carbon steel. Not 100%, 50%. So
it's not available.
Because it's not available. Not available if we need the facility within the next 2 years. So unless we drive the market, and the market is changing, but unless we drive the market collectively, everybody that continues to buy regular steel, regular concrete is not allowing that shift.
No, I mean, I had the same conversation last night around like these low carbon gas turbines. They can't produce them fast enough to meet the demand for the requirements. Are you seeing, Sophia and Ed, with your projects, that there's a demand for you to provide carbon emissions as part of the design side of things?
Yeah, it's normal now. It's gone from not really being even a conversation 10 years ago, increasingly talked about. Now it's pretty much the norm. I would say most organisations have still got a long way to go in terms of accuracy. I think there's a lot of chucking numbers at it. But
yeah, and I think just coming in on that point, actually, if you've got a batching plant or a manufacturing plant in the UK, the level of data, we talked about it earlier, the level of data for materials like that from call it an EPD or the sustainability footprint, if you like, is actually getting really good. The M&E plant is really difficult. Yeah. There's a bunch of stuff that exists around the edges on TM65, but actually the cost and the impact to these guys to getting accurate data for all of their range of equipment, because they're assembling multi-component product from around the world. That's a long way off.
But then it becomes a question of holding your own supply chain accountable, right?
And this is where we're now seeing a shift in terms of our own in-house responsibilities. Is we're seeing now the specifications driving the need for this type of information. And the truth is that there was probably a little bit of a disconnect in terms of it being defined by people like Ian and the consultants to say this is a requirement, and then manufacturers actually being ready to deliver that information as part of construction projects that are ongoing. So we're now in a situation, of course, where we're working incredibly hard to make sure that we have that embodied carbon information available for the majority of the portfolio. But of course, the less standard designs are, the more variances, the more level of special engineering we have.
But the next
to do, the more
stage is to
complex
bring the
that
cost
becomes.
down, right? Once you've got all of this data, and then you've got you're driving supply, then in theory the green premium attached to those types of things should start to go down. So we're moving in the right direction. Sorry for taking over, Loren.
you always do.
I know it's a habit, isn't it? I think it's
The other thing I would say about kind of innovation in construction and things like that, we're having to go back to school, right? Because we're having to become chemists and biochemists and biologists to understand how raw materials, how nature deals with carbon, and learn from that and see how that can be adapted to solve some of the problems we've got. So we found ourselves having to invest in scientists and data analysts as a data center business that would be unheard of a couple of years ago, 5 years ago. And I know our customers have got deep pockets and spend an awful lot of money there. But you've got to keep looking at these things to stay relevant, I think.
Yeah, well, we talked about Doug at Meta and what he's, it's kind of like an Apollo 13 of you dump everything on the table and you throw out what you don't, do I really need this? Do I really need that? And you, going back to what you said, you try to do the same or even possibly more, but with less.
Yep.
So.
And on that point, thank you very much, guys.